Good morning, boys. I'm Captain T. Kumar. Of course, I was taking your class. Uh, what we are doing? We are doing the gyrocompass. So far, we did the principle on which the gyrocompass works. That includes the inherent properties. And then how that free gyroscope behaves on the Earth's surface, we have discussed. Then we have discussed how that free gyroscope can be terrestrially stabilized. Then we have discussed in different stages how the gyrocompass can be made north-seeking, right? Like through undamped gravity-controlled gyroscope and then damped gyroscope. Now, what I will be discussing, that is the gyrocompass, the errors. What are the errors could be on the gyrocompass? Right. So, gyro errors. Gyro errors, you see, there are your alignment error, then transmission error, TX, very short form I'm writing down, TX transmission, and then latitude error, LAT, and then course and speed. See, I have put it in a very short form, COS and SPD. Course and speed. And then you have that is wandering error. Under wandering error, you have rolling, and then you have ballistic. So these are the errors which are there. We are going to discuss. Now, first we talk about the alignment error. What is alignment error? Alignment error is that is the difference between the indicated heading of the gyro and the ship's fore and aft line of the vessel. Now, when I say indicated heading of the gyro, how the gyro heading is indicated? That is by means of a level line, all of you know. So, it is the error between the level line and the ship's fore and aft line of the vessel. So, you don't need to do anything about this, any correction on this. Normally, this part is taken care of by the distinguished technician while mounting the gyrocompass, and they ensure that this level line is always in parallel with the ship's fore and aft line. That is taken care of. But yes, in case if the level line say shift, so that can be treated one of the correlated error of the gyrocompass. That of course you are finding out once in a watch, that is to be treated as that. And you are finding out the gyro error, isn't it? Like you're taking your terrestrial objects and taking the azimuth, taking the transit bearing, and then what happened? You are documenting in the gyro error book. That is once in a watch, which is done, and that includes in case if any error surfaces because of this alignment problem. Okay, other one is that transmission error. Transmission error, see, master gyro compass is kept where? That is below the steering panel. So rest of the compasses, what are being used, like your the compass which is being used for steering purpose, isn't it? Or say center line of the vessel, or say port and starboard side. These are all repeaters of the master gyro compass. So there are how many repeaters are there? Like your steering, center line of the vessel, port side, port wing, I mean, starboard wing, then your steering flat, course recorder, right? Then radar. So the inputs are provided. Normally the master gyro compass, all the movement which is transmitted to all these repeaters. That how it is this thing you transmitted, that normally it is your, I can say, not remotely, of course. It is all connected by means of the cable. I'm not going into details about the transmission part, but just very brief, what I can say, that one transmitting unit is coupled with the spindle of the master gyro compass, and this transmitting unit is connected with another reception unit, that is each and every repeaters, and this reception unit again is coupled with the spindle of the repeater compass. So each and every movement is transmitted to the reception unit, and finally what happens, it aligns with the master gyro compass. That is the arrangement which is there. But yes, the error may result like how the attachment is there, that is by means of some gearing devices, whether your transmitting unit to the spindle of the master gyro compass, or reception unit with the distinct spindle of the repeater compass by means of gearing devices. So now if there is a slipping in teeth, then what will happen? That particular repeater may go haywire with the master gyro compass. Or the cable which is being used, you see, if the ship becomes old, there are a lot of stresses like vibrations, which results this cable to break. So there will be on off, and that way the master gyro, repeater compass, may go out of line with the master gyro compass. So that is what the transmission error. And this transmission error, the error actually you are supposed to find out this thing once in a watch. Once in a watch, like during handing over, taking over, you require to monitor the master gyro compass and each and every repeater compass, whether they are aligned or not. If not, suppose any repeater compass not aligned, then you will find that the repeater compass, there is a switch, the spring loaded switch. So this switch, if you press, then what happens? It de-energizes the coil in the reception unit, so no magnetic field, and it can be turned very easily and it aligns. That is how it is done. Or maybe another type of model, this thing, you can just press, it disengage the gear from the spindle and it becomes free to move, and then it can be turned, and once it is same in line with the master gyro reading, and it can be reset. That is how it is corrected. So that means due to the transmission error, your repeater compass may go misaligned with the master gyro compass, and that is the reason you are supposed to check each and every repeater As I said, once in a watch, arrival departure port is part of the this thing your control testing. It is to be checked. So transmission error is gone, right? Now next we talk about the latitude error. What is the latitude error? Okay, already discussed in the last class that is same as the damping error. Same thing. Latitude error. Why the latitude error is caused? Because of unequal rotational speed on the Earth's surface. Like when you are standing on the equator, you are moving through the space about 900 nautical mile per hour through the space. And if you happen to stand, on 60 degree, then you will be moving through the space about 450 nautical mile per hour. So because of this variation in speed on the Earth's surface, this error results. But this error, yes, is prominent. Sorry, only those kind of gyro where this gyrocompass is your thing made north checking with your bottom heavy arrangement, and if it is a top heavy arrangement, this error doesn't arise. But anyway, so latitude error, that means that is same as damping error. And what is that correction? Correction is equal to 1.44 tan lat. That already I explained in the last class. 1.44 tan lat. Now, how this latitude correction can be corrected? Yes, you will find that if it is a manual type, that is a scale is provided, and here say 70 degree south and here 70 degree north, and this is the center, and here you have a knob. This is the scale. So this is the 0 degree. Okay. So whichever latitude you are on, you just turn this knob and it moves along the ratchet, and that particular latitude once it is, then what happens? Now again depend upon model to model. Some model what happen, if it is a purely mechanical type, it connects with the your level line by some mechanical linkage. So by putting on a particular point, then the level line moves by equivalent amount. That is a mechanical linkage. And if it is an electrical type, then what happens? By putting in the particular latitude, the amount of voltage is created, because the amount of voltage depending upon the what latitude you are on. So the amount of voltage which is created, and that presses the gyro ball equivalent amount. That is how it is correct. This is latitude correction. Of course, modern ships, what you have the GPS. So what happens? It takes the input from the GPS, that is the latitude. So depending upon the value of the latitude, it creates the voltage as the feedback, and that presses the gyro ball again equivalent amount. That is what to be done. So that means you have to ensure that every day, if it is a mechanical type, every day